That's 3 seconds, right?
It's, yes. Mm-hmm.
So this is time. Time in seconds. This is velocity in meters per second. 1, 2, 3, 4. And it's just a straight line like this. Sort of.
Okay, so I need to find position, velocity, and acceleration when x naught is 2 meters
So, yeah.
at t naught equals 0, and at 2 seconds we need to find the particles. Position, velocity, and acceleration.
Okay. So do you remember talking about these things? So you have position, velocity, and acceleration.
Mm-hmm.
You want to go this way? What do you do?
I'm not sure. Like, is there a formula we use for that?
Well, they're related to one another.
Okay.
And it's like a calculus
Mm-hmm.
relation.
Okay.
So if you had a, say, an equation for position and you wanted to find velocity.
You could just switch it around and find them, right?
Yeah, and you take a derivative.
Okay.
If you want to go the other way,
Integral?
take an integral. So you've done some calculus before, right?
Yeah, I'm in Calc 2.
Okay, great. So what does the derivative represent graphically?
So it takes like the positive side of the graph.
Takes the positive side of the graph. Well, just like on the graph, if you were to look at a graph and wanted to find out the derivative at a certain point, you'd look at a tiny little change in x and a tiny little change in y,
Mm-hmm.
and then you find the slope right there, right?
Right.
So a derivative, graphically speaking,
Mm-hmm.
is looking at the slope.
Okay, yeah.
And then, so we can kind of put that up here on a graph.
The slope,
You
yeah.
look at the slope. And then what does an integral do if you're trying to integrate something based on just a graph?
So it does the exact opposite of that, right?
Sorta. It's kind of hard to do the exact opposite of finding the slope, but
Right.
you remember like doing rectangles like this,
Mm-hmm.
that kind of stuff.
Yes.
And then you make them smaller and smaller, so then
Until you
integral
can get the whole area underneath your graph.
finds the area underneath
Yeah.
the curve. So area. So these things, they'll just come up over and over again. You use them all
Yeah.
the time. So for this one,
Mm-hmm.
which one, what do we start with? What is our graph of?
It's the velocity graph of a particle moving along the x-axis.
Okay, so we're starting right here.
Mm-hmm. So this is, so we need to find the position of it now.
So how do we go from velocity to position?
Take the derivative of what we're doing.
From velocity, we want to go to position.
So integral, we want to go to the
Yep.
integral. Yeah, not the derivative is going the other way.
Mhm.
Okay. So we have like at x naught, it's 2. We want to find what it is at 2 seconds. So where do we start? Like, do we go to the 2 seconds and find that first?
Yeah, so you can just draw a line at 2 seconds
Okay.
and then find this area right here.
Okay. So it's just finding the area.
Yep. So once you know the area under this,
Mm-hmm.
then you know how much it's covered in those 2 seconds.
Okay. Do we have a formula for that?
Just for the
Yeah.
area?
Yeah.
Well, it's a triangle.
So you just do base
do-
times height?
Mhm.
Okay. So it's just 2 times 4?
2 times 4, and then, so that would give you this whole area, right?
Mm-hmm. Then you divide it by 2?
Yep.
So just 2? The answer would just be 2?
Close. So that would be how much it's moved from
There.
time 0
Mm-hmm.
until time 2. What does it tell us about where the particle is at time 0?
Is it 2 meters? Or,
Mhm.
Yeah, 2 meters.
So it started at 2 at
Okay.
time 0, and then it went 2 more.
Okay, so is it 4 then?
Yep.
So 4 divided by 4? Or
Um,
4 times 4?
It's just, you just add them to each other.
Add the 4s together?
So let's see, you have 2 times 4,
Yeah,
oh, that'd be 8,
right.
plus 4. So your change in x
Yeah.
would be equal to 4 meters.
Yes.
So that's from time 0 to time 2.
Yes, is the 4 meters.
But x of 0 equals 2
2.
meters.
Mm-hmm. So
So your final position would be, if you have 2 meters and you change 4 meters
to
positively.
6
Yeah.
meters.
So your x final, or your x at 2,
It would be 6.
would be 6
Because you
meters.
add them.
Yeah.
Okay.
So that's one thing when you're integrating and you're looking
Yeah.
at a graph,
Mm-hmm.
you have to remember that when you integrate, you remember doing this, you have to do the
Yeah.
integral of whatever f of x equals f of x.
Mm-hmm.
But then what do you have to add over here?
Oh, jeez. I don't know.
It's a plus c.
Oh, yes. Okay, yeah.
Because this one right here.
Because that's just that's the number, right?
Mhm.
Yeah, okay.
Yeah, that disappears when you take a derivative.
Right.
So if you look at the graph of position, it could actually start at any point and it would still
Okay.
give you the same velocity graph.
Okay.
So you just have to remember that there's a plus c in there,
Okay.
and it'll usually be given to you. That's why they said at time
At
equals
time.
0,
Okay.
x equals 2. So that's x of 2 is equal to 6 meters.
Okay. So now we need to find the velocity.
Uh-huh.
So if we take the derivative or the integral of that, because it's already a velocity graph.
So it's already a velocity graph.
Mm-hmm. So we're already there. So we're not going up or down.
Right.
So.
So we can just look at our value, right?
Mm-hmm.
So this says, this graph is telling us at time 2, velocity equals actually 4. My graph isn't very good, but,
Yeah.
right?
Mm-hmm.
So time 2,
At time 2, it's just 4.
yep.
The answer would just be 4 because you just can look at the graph and find that,
Mhm.
right?
Yeah, you don't have to take a derivative or anything, really, just look at your graph.
Okay, so now we need to find acceleration. So now we need to find the derivative.
Yep.
So that's just the slope.
Mm-hmm.
Okay, so if we start at 2, is it just 1 over 2? Is it just 1/2?
It'll actually be, so at 2,
Mhm.
you rise, right? You
Yeah.
Rise over around.
Mm-hmm.
How far up have you come?
4,
And then how far across have you come?
2.
So you want to do 4 over 2.
Okay, not.
The slope of
I
2.
did it backwards.
Mhm.
Okay, that makes sense. So you can just use that whenever you're looking at a graph, right?
Mhm.
That little deal we have going up there.
Yep.
Okay.
There's probably some more questions about graphs in there, right?
Yeah.
So we'll get some more practice with that. I'll just leave it up there.
I hate graphs. Okay, so. These questions take forever because they have like 17 parts.
I know.
So problem 11 really has like 7 problems in it. Okay, so we're looking at a velocity versus time graph for a particle moving on the x-axis. So we need to find the position at 1 second.
Okay, so this one
Mm-hmm.
is a little bit different just because of the way the graph looks, but what is it? It starts at 4,
Yeah.
and that's for 2 seconds, and then it drops down to 0.
Yeah.
So this is at 2 seconds, this is 4 meters per second, times seconds. And what time does it hit 0? 4?
Yeah.
So you want to find position at
2.
2, or at, what are the
2
particles?
At 1 second, I mean.
Yeah.
Yeah, that's what I mean.
But what you're looking at is the initial position is x
Yes.
naught. So let's write that over here. X naught equals 2 meters.
Mm-hmm. And we're looking for it at 1 second.
Yep.
So 4.
Yeah, so that's the area under this curve.
Mm-hmm.
It's 4. So what's your position at 1 second?
Wait, is it not 4?
That's the change in position.
So you just have to find your position. How do you go from change in position to? Would
Well,
it be 3?
If you think about
Well,
this,
minus 1.
like this little thing,
Mm-hmm.
equals f of x plus c.
Right.
What you found is this f of x.
Okay, now we need to add c.
Yep. So what's your c gonna be?
1. Or 2, because
Yeah.
that's the initial,
Mhm.
right? Okay, so sit.
Mm-hmm.
That would be right,
Yep.
even though it's not on the graph.
Right, exactly.
Okay.
So the graph only shows you 4, but
But-
that's only telling you how far it's moved from 0 to 2.
Okay.
It doesn't tell you where it started. It
Okay.
can't tell you where it started.
So that's why it gives us the initial, so we can plug that in. Okay, so now we need to find the velocity at 1 second. So it's a velocity versus time graph, so would that be 4?
Yes.
Okay. So then we have acceleration at 1 second.
Mm-hmm.
So now we need to find the derivative.
Yep.
But it just wants us to do this all over again. So at 3 seconds instead of 1.
Okay.
So we need to find the area of that whole thing.
Yes.
So since it's slanted and not like a rectangle anymore, how do we do that? Do we just break it into parts?
Yeah. So you can, you know what this area is going to be, right?
Yeah.
All of this. And then you can pretty easily draw a line over here. And this just gives you a square.
Mm-hmm.
And then find this area right here.
So we have 4 plus 4. So 8 is the first big rectangle, right?
Yeah.
And then the little rectangle would be 4.
Well, this is a
Not
change
4.
in 1.
It would be 2.
Yep.
So 8, 9, 10. And then we have half of 1, so it's 1. So 11
Yep.
is the area underneath.
Mm-hmm.
So that would be the position. 11 meters, right?
Well, so you found the area under the curve, that's the change.
Okay, so then we need to add 2 again.
Yeah.
So 13.
Yep.
Okay. Because that's what the C is.
Right,
So, okay.
exactly. Or the other thing you could have done is said, well, I know that my position at 1
Mm-hmm.
is 6 meters.
Right.
So I can just find this area,
Uh-huh.
and this would be 4, 8, there's 4, 6, 7.
Yeah.
You'd be able to say, okay, this area is 7, and I add it to my initial condition here, which is 6. That
Okay.
gives you 13 again.
So then velocity at 3 is just 2.
Yep.
And then acceleration. So we did this already. So now we're over here going down. So that means we have to find the slope. And we do have a slope now, right?
Mhm.
So it's going to be 1/2,
So you're at 4,
right?
you went down to 0.
Mm-hmm.
So that's a rise of -4, right?
Over 2.
Yep.
So it's just -2.
Yeah.